Hi guys, this is Daniel from Make, and in this video we are going to look at how to handle inconsistent inputs which you may sometimes get. So what do we actually mean by inconsistent inputs? Imagine you are working with an API or with an app which can have two small flaws in it. First one can be the fact that the data you get is not always present under the same keys. So the keys might be randomly changing, not the values, the keys. Yes, we've seen that happening. And the other problem you might encounter in your real life scenarios is that a key can change its data type without telling you. So sometimes you have a key which comes as a string. Then the next time you run the scenario, this key will produce a number. Next time it may produce an array, and next time it may produce a collection. And you still need to handle these situations if your subsequent modules are, for example, expecting just a number or just a string or just a collection. So in this video, we are going to look at how to handle these situations. So let's start with changing keys. I have prepared this scenario with two routes. So the first one will obviously be about the changing keys. The other will be about changing data types. So we can run this module and see what data it produces. So we can see there is a dataset array with two collections in it. And here we have Joe Doe from San Francisco and we have Paul Smith from New York. And imagine this key is kind of weird, right? This one is nice. It's first name, last name, as you would expect. But you know that this actually represents first name and this one represents last name. But as you run the scenario or as you run the module over and over, you are actually noticing that this key is changing. You see, now it's ending with 93. When I run it again, it's going to end with something else. A7. I can run it again, and again, it's going to end with something else. Nevertheless, you still need to figure out, for example, the full list of first names from this data set. And you know that, for example, when a key name starts with first and hyphen, that's your first name. So you kind of know the pattern, but the problem is that the key is changing, and therefore, of course, you cannot really map it in subsequent modules. So how to go about it? So let's first run this route, and let me show you that it is actually possible to do. So here I'm ending with a text aggregator, which is simply giving me text, and it's the two first names from that small data set. So currently it's possible, but now the question is how we can actually do this. Let's look here what I'm doing. So obviously you will need to iterate through the data set. So it's an array with those collections. Then you will need to use get function to get individual collections from the data set. So what I'm doing here is basically I am getting the full data set and then I am getting individual collections based on the position in that data set via the get function. And then finally, this is the main trick. This is what you should take away from this video. I am using the keys function. So let's look at what the keys function actually produces. First of all, we can hover over it and we can learn what it does. So it returns an array of a given object's or array's properties. Okay. So when I see this, when I see the output of the module, we can actually see that it is producing the keys of those individual collections, right? So I had two collections in the data set here. So for the first collection, it's giving me first name, last name, and the city. Here, I have the second collection, and from that second collection, it's giving me those dynamic keys. So it's giving me the first hyphen and the random string, and last hyphen, random string, and city. So far, so good. If you know how to use the get function, the rest of the scenario should be a piece of cake for you. So what we are doing here is that we are actually iterating through the keys variable, which I set here. So it's gonna basically take all individual keys, right? First name, last name, city, then these dynamic ones. And then I'm filtering for keys which only contain first. I could be more strict. I could say first and hyphen, or I could be even stricter and I could say again first hyphen and text operators starts with. This will obviously give me the keys which are matching the condition. And here, what I am doing in the final step, I'm using the text aggregator and I am using again the get function. So I'm taking the full data set. Then again, I am mapping the bundle order position basically, right? So this is the mapped item. And then I'm using the dot notation to get the actual key from that collection, right? And the key is coming from the preceding iteration from this module. The bundle order position, or basically the offset of that collection, is coming from this module. And just like that, you can get dynamically the values of those changing keys. So let me run it again. Here we can see that this key passed, right? Because it's matching the condition. This one didn't, this one didn't, this one did, because again, it's matching the condition and the remaining ones did not. Finally, we get the output and it is Joe and Paul. We could be a little more efficient here. As you can probably already guess, I can just copy and paste this and save some operations. So instead of setting the keys variable here, I could remove it completely and just start iterating through this nested formula. And when I run the scenario, I'm getting the same result. So remember, if you are having changing keys in your data source, it's not lost. You can still solve it. And the keys function is your friend. Maybe the last thing, which I have not shown yet, where you can actually find the keys function. And of course, it's here under the arrays functions here. Let's now look at our second problem, and that is changing data types. So I'm going to disable the previous route. I'm going to enable this one. And of course, I will give you the data again. So head below the video. The link is there, so you can try. Let me run the endpoint first. And we can see that we are getting an array of results. And the results are simple collections with a data key, which is not changing this time. And here we get a number. Here we get a sample text or string. Here we get a one-dimensional array. Here we get an array of collections. And here we get just a collection. And now imagine you are running a live scenario and all of a sudden you are getting outputs like this for something which maybe was giving you just numbers or maybe just strings, right? But your subsequent modules are expecting the data type. And because those subsequent modules are expecting the specific data types which you have previously set, and now they are getting something else, they might be failing, right? Because if a module is expecting a number and all of a sudden you are sending an array to it, it's likely going to fail. So how to address this situation? Well, first of all, you will need to figure out the data type of the data which you are getting, right? So you will probably want to know whether this is a number or whether this is a string or whether this is an array or this is a collection. And then based on your findings, you might be able to introduce multiple routes and maybe handle arrays differently, handle collections differently, or handle numbers differently. So the obvious question is how to actually determine the data types. Unfortunately, when you go to our functions list, the default ones, there is not a nice function which will tell you what data type an incoming value is, right? So even if you keep looking, it's not there, at least not now. So the question is there any combination of nested functions which you could use to determine whether the data or whether the actual value is a number, is a string, is a collection, or is an array? And of course, there is. There's always a solution. So when we look closer at this nested function, what is actually happening here? So first of all, I check whether the incoming value is a collection by converting the actual value to string and checking whether it's equal to object in curly brackets. Because if it's a collection and you convert it to string, this is what you get as output from that toString function. Then I'm checking whether the keys of data, in case it's an array, is greater than 0. Because if the value is an actual array, it will have at least one key. Therefore, I know it's an array. And here I am checking whether the value is equal to sum of that value. And if it's equal, I can say it's a number because, for example, if the incoming value is a text and I run sum over the text, the sum function is going to return 0, and therefore this will not be equal, and therefore I know it's not a number. And if none of the previous conditions or none of the previous ifs find a match, I know that the incoming data is text. In order to better demonstrate what's happening for each of those incoming values, I've prepared this helper module. So I'm doing toString over data, I'm doing keys over the data, and I'm also doing sum over the data. So when I open the outputs, we can see that when the actual data is 555, toString is 555, but we don't care too much, but the sum here is 555. So when this is matching, we know that the incoming data is a number. Here, I have the data, which is the collection, and the toString function is telling me that when I try to convert the collection to a string, I'm getting this output, and based on our conditions in the subsequent if, we know that when this happens, the incoming data is a collection. Here we have an array of collections. So when we run the keys function over that array, it's going to return the keys. And when the length of this array is higher than 0, it means that keys exist. We know that it's an array. And this trick both applies to these more complicated arrays with collections and even to simple arrays with one dimension, right? So this is just simple array. And finally, when none of those checks match to anything, we know that the incoming data is a text. So in real life, when you finally discover what the data type you get, let me run it again. You can address the problem, for example, with router and say, hey, if my data type is number, then execute this route. If my data type is array, execute this route. So let me finish the scenario a bit now, and I will then run it and show you what the results are. So I'm just going to set a few variables here. So here, going to be x, and here going to be epsilon. I'm going to delete this one. And let's go. So here in the results of this module where we have the formula magic, we see that 555 is a number, sample text is a text, this array is an array, this simple array, this more complex array with collections is also an array, and then finally we can see that collection was determined as a collection. We can also see that in this filter we were checking for data type when it's number, so it would pass. And in this other filter we were checking for data type equal to array, so these two bundles would pass. And that's really it. So you can clearly see the formula is working, and I strongly encourage you to use it when you need it. Now you know how to handle the two types of unfortunate situations where your keys are changing or where your incoming data has changing data types. So I hope this was useful. And a little spoiler alert is that you may need some of these tricks in the level 5 challenge. Good luck.